Hello everyone. Today's video is not going to be about a new topic actually. I just realized that the first video on this channel, which is about the introduction to OLS linear regression, was taken down my YouTube. So this video is to replace the previous one that was lost. But this time I am going to do it a little bit differently. I'm not going to include how to use Excel since Python is becoming more and more popular. So I thought I should show more on the Python. And also this video is the first of a series of video that will subsequently be uploaded showing how to code in Python for both uh, basic and advanced regression technique. But this video is since this video is the introductory video, the objectives are pretty simple and straightforward. So I break it down into two parts here. The first part has nothing to do with regression. It is more like setting the stage for regression, and then second part we will do the linear regressions. So let's get down to business. First and foremost, as usual, to use Python, we need to import a few libraries. So first, let's import Panda as PD, and I'm going to import the Statsmodels.api as SM. There are other libraries that you can use for linear regression, or not just linear regression, for any other types of regressions. But since later on I will be doing more advanced statistical analysis, it's better to use the most advanced library available now, which is the stats model. And I want to import matplotlib.pyplot as PLT. The reason is that in my objective here, I want to plot the data frame, the original data, as a scatter diagram, and also use the regression line. So for that, Matplotlib may be very handy. So importing the library is done. That is good. So what about the next step? In the next step, I want to read this data CSV file into the data frame. When you look at this, it's not complex. You just have three columns, but the first column is just the observation, indexing the observations. You have price and the sales, and I want to find out the correlation between the price and sales. So let's read that. I will call it data frame and pd.read CSV. I just input the name of the CSV file as a raw.csv, and let's look at my df. It looked good. However, there is a small problem. If you look at your df, you have read CSV create an additional column here. I don't want that. So can I get rid of it because I already have the observation column? Of course, you can change that by just say index column equal to 0. Basically, I'm saying that the first column should be used as the index column. And this is your DF now. Pretty easy, right? Okay. And the next step, in the next one, I want to show how to sort a data frame. It's nothing complicated. Okay, so if I want to sort the data frame, I will create a new variable df sort, and I will use this sort by values because I'm going to sort it by value. And by what? Sort value, I think this will be price, sort by price, and I think I need to put x is equal to 0 because I want to sort it along the column, not along the rows. And I hope nothing bad happens. Yes, good. So now your price are arranged from 51 to 57. So remember that your minimum price is 51 and your maximum price is 57. And just like in Excel too, you can find out the mean, median, and mode in Python, and it is also very easy. You just have to call it mean, or you just have to call it median if you want median, and mode if you are looking for mode. So you see, for sales you have two modes. For price you only have one mode. That's why you have NAN here. Good. And the next one, I want to plot this data frame. Uh, at this point, I don't need to use Matplotlib, because if you go to let's see, Matplotlib, Panda data frame plot, you can see that uh, Panda already have the built-in plot function, so I'm going to make use of that. So let's say df.plot, and my x is going to be price, my y is going to be sales, because y is the dependent variables, sales is the dependent variable, sorry, and I want it to be scatter. Maybe I don't need to specify, but it's okay. And the color, I want it to be red, and you can also specify the size of your plot. Let's make it 10,5, and there you have it, your plot, a scatter diagram. Later on, at the end of this video, I'm going to add a regression line to it. Okay, so this first part is pretty much done. We can move on to the second part, which is the linear regressions. So before we do that, let's create some variables. So we have dependent variable, which is the df sales, and explanatory variables, which is df price. And once I have that, can I do regression? Not yet, because if you look at the 7 assumptions of simple linear regression, the first one states that it must be linear, and also dependent variable is governed by not just x, but also by the constant term alpha. For the stats model library, you have to specify the constant. The stats model will not add it automatically. So to do that is easy, because if you look at the explanatory variables, you only have this price column, but you don't have the constant column. Adding that is not difficult. It can be done in just one line. I say sm.add constant. Sm is a library you already imported at the beginning. Explanatory variable, and let's look at my explanatory variables. Now you have the constant column. Cool. So we can do linear regression now. A lot of times, students, especially students are just who just started learning Python or MATLAB or R, they will ask, how do I know what to look for? How do I know which code I need to write to do linear regression? The answer to that is you have to read the documentation. So you have this page, and if you look at that, you can see the OLS regression, because we are doing OLS regressions. And also you have the classes. I click on OLS. These documentation you must read. You must read it patiently. Patience to read documentation, we get half of the job done. Okay. So when I look at that, you see here, they say how the regression was done. So I'm going to do the same. I'm going to copy this, but I will type it out. Okay. So I say model, which is a regression model. What model? My model is OLS, and y is the dependent variable, and x is the explanatory variables. And I will have the result. Result will be model dot fit, and I can print the the result summary. And there you have it. What I have is the same as what is shown here. Um, so you already done the linear regression. You can look at the R square value here. You can look at the values like AIC and BIC. But some student will ask, how do you know that after you do this OLS, you get the model? How do you know that you can call fit function on the model? And how do I also know that the summary can be applied to the result? Again, the answer is on reading the documentation, because if you look at if you come here, you have this OLS class. For you, your model is the instance of OLS class, and 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 on that I call the fit method. So how do I know I can use fit? Easy. If you read here, you see the method fit here. So you click on that. When you click on that fit, you look at the return. Your return is a regression result. So I click on regression result again. That is also the class. So when you do OLS, sm.ols, your model is the OLS class, and on OLS class you have fit method. If you call fit method on it, the result you get is the regression result class. And what can you do to that regression result class? There are many ways you can do. See, you have many methods that you can use, and summary is just one of many you can use. So I use summary, but there are other methods that I can use. For example, let's do easy one like confidence interval. So I can call the confidence interval method on the result. Uh, that will give me what? Easy. Look here, for these two parameter, constant and price, you have the confidence interval lower and upper limit for the confidence interval, 95% confidence interval level. But can I just extract these four values from the result class? Yes, you can do that. So you can just call it result. So I will make it into confidence interval equal to result dot confidence interval. My mistake. There you have it. You have this four value, which is the same as you see on the summary page, summary table. What if I want to extract only this value, say 17510.6761? Of course, you can do that. If confidence interval is the data frame, how do I know? I just type confidence interval, which it will tell me that confidence interval is the data frame. So to extract this 175.0.6761, I can just say confidence interval.log. I am looking at constant and I'm looking at 0, and you get the values. Okay. So you have seen that there are a lot of methods that you can call on the regression result class. Let's do another one, simple one like predict. So how do I do that? Again, I have the result class, and I will call predict on it. So predict what? Um, now you already have the regression model, and your price value are from 51 to 57. But based on the model, you want to predict how much sales you will have at the price of 58. Can you do that with in Python with this predict function? Yes, you can do that. I want to find out the sales. I want to predict the sales for a price of 58. So let's see. You get error message. Why? If you think about it, your input must be constant and x. So your input might be constant and the price. So 58 alone is not enough. Also, and also if you read the documentation, your input must be array-like. So I want to change it into something like an array, but if I cannot just put 58, that will still give me errors. But if I put like 158, you get the predicted sales value, which is about 85. Um, can I change to 58 and 1? Of course not. You will definitely get an error message. Oh no, you don't get error message, but your value doesn't make sense because you already seen that your explanatory variables constant come first, followed by the price. So the constant term 1 should be the first, followed by the price 58, and then you get the predicted sales. Um, so go to so don't be afraid to read the documentation, and you can explore using various methods. You will find most of the things that you need here. Okay, and also we are coming to the last one. The last one is I want to add the regression line to the scatter diagram I already have. So this time I'm going to use the matplotlib. So I will call it my plot, and I'm going to say plot figure, and figure size equal to, I use just now 10,5. Okay, good. And for my plot, plt.plot, what should I plot? df uh, price. Oh yes, x is price, and df sales, and I want it to be a color is like red and dots, and I will give it the labels. Uh, I just call it data. Okay, then you have this scatter diagram, which is the same as what you did just now. But this here you are using the df plot function, but for the second one, I am using the matplotlib, but the scatter diagram is all the same. But the last one I'm going to do it, I want to add the line here. So I will do it by adding another line, call it another plt.plot. I'm going to plot x-axis remain the same, price, but for my y is going to be the predicted values I got it from the model. So it would be result dot what values. Again, this one is for the regression result, right? um, and you come down and you will see that it has a lot of properties. One of them is the fitter values, that is saying the predicted values of the model. That will be your y values in your regression line diagram. So I'm going to say fitter values. You don't need the bracket here because this fitter value is the properties, is the attributes, it's not the method. So just fitter values, and the line I want it to be blue with a dash, and the label I will give it a name as uh, a regression line. Uh, yes, but it's not showing me any labels here. Let's see what mistake I did. Yeah, that is strange. Exit plot xy label equal to data. I don't know why. Uh, maybe I should use. Not very sure. Anyway, at least now you see the regression line here, and yeah, so we are done. So this is the introductory video showing you how to use code in Python for simple linear regression. In the next video, I will be showing how to do multiple linear regression in the Python with using Python. So please look forward to it, and thank you so much for your time. Bye bye.